Hi everyone. Am I audible? Am I visible? Are you able to see me? Hey Animesh. How are you doing, man? Hi everyone. So, hi Omkar. Hi Manthan. Hi Rishabh. Hi Kanika. So, it's a small tradition we follow whenever you join in the class, and whenever you just join in, you have to just tell, okay, we have joined in, and I would set a word on the Discord channel that we are live. Okay, so I'll just wait for next. Yeah, hi everyone. There is an echo in my voice. Thank you so much. Been missing you yet? Uh, Let me figure out why there is a echo in my voice. And till then, you can just tell in the chat what you have been doing so far, what you are learning, and how it's going on. How are the placements going? कई सारे लोगों के placements start हो गए, and there are people who are going through placements right now, right? So you can tell what is your experience with the placements. Are they good? They are bad? So I struggled a lot. If you can say you're struggling, I struggled a lot. And just tell me about it. How it's going? How has everything been? Okay, so before everything, so I created a video for you. So data structure and algorithm. So you thought we are going to start with a presentation, and I'm going to show you a presentation, and then I'm going to take you through a presentation. So I didn't do that. I generally do things with a presentation, but I didn't do that. I have created something for you guys. So I went to the park today, and I really wanted to show you that what is the true essence of data science, data structure, and algorithm. So I have created a video for you. I hope we'll share the audio too. Okay, so this video is for you, and I've been explain. I wanted to explain something through the video, and I really wanted to do that. And I've created this video. Thanks, Robin. Hi. So this video is basically how we are going to do data structure and algorithm, and how we are going to take ahead with this. So let's go ahead and tell me if audio is available or not, because I'm. Hi guys, this is Prakash Pathak, and you must be wondering that this was data structure and algorithm class. So what I'm doing out here, right? So this was supposed to be shooted in the morning, but it's afternoon now. Sorry for being a lazy guy. So today I'm going to explain what is data structure and algorithm, and you're really wondering why are we out here. So what? So you have to understand the concept that what is programming, and programming over here is the manipulation of data. And I'm here because of there are stacks of concrete bricks, which is in the back. I'm going to show you how data works and why it is very much required. So, for example, if I take this concrete, okay, this is very heavy. Yeah. So this concrete piece, take this as a data, right? So if I put this data over here, this means something to you. I have put this data. This is meaning something. Take it as a backend data, and this is working as a backend data for you, right?
this is just one stack of data. And I want this backend data to be used as a front-end thing, right? So I would be manipulating that data so it can be converted into a web app, it can be converted into a website. So this is all you can see is data we have with us. And this is up to us that how we keep the data and how we stack the data. So I can keep it like this, right? So this is what? This is showing the front for it. Just try to imagine with me. And this is the front end of the complete code or complete algorithm. And there is a back to it. So I need a support. I need to support this code with something, right? So for it, I will also I'll take one more data with me. And I will support this with this, right? I have stacked it. I have stacked it in a way that this will support this particular front end. And I'll stack more. As you can see, the moment I stack, it would support the front end of the complete thing, right? You're seeing it that to support this, I'm stacking more data beside it. This can be counted as, could you just come over here? This, what I'm creating over here is the back end of the complete thing. I'm just taking the data, manipulating in it a way that it supports the front end on it, right? So if you're understanding the point over here, why we are out there and why we are using it, it's only because to know how we are manipulating things. So that is what is data structure and algorithm. Why you need it. So if you just come closer and you see that if you see the structure, right? This structure, does it remind you of something? Does this structure remind you of something? I guess it does. It looks like a tree. You see the stack of data, how it has been stacked. It looks like a tree, one connected to the other connected to the other, supported by it. So this is how data structure and algorithm works. This is the core and basics of programming and engineering we are going to do. And why we are out here is just to explain that these things are so much related to our day-to-day world around. So this stack is a very good example of how a data can be kept. Okay. So the best example for a full stack application would be this. Okay. So you see this complete structure over here. Think it is a complete full stack application built on something has some functionality. For example, this is an API service, right? And I am the user over here, and there is the data over here, right? The data I need to call in. So for that, I need a sequence to go for fetch that data and use that data to come back. So this API service is what it's doing. It's creating a channel. It's creating its channelizing over this full stack application. This full stack application is an API service application. If you don't understand APIs, you just have to Google it. It's a very simple thing. So this complete full stack is an example. And now why do we need data structure and algorithm in this? Just understand, because this channelization, this can be done in the complexity can be so later in class I will explain about the complexity. What is the complexity? Space-time complexity is the main. So the time that takes me to go from there to there, can something be done to do something in a very efficient way? So that by that we need data structure and algorithm. The reason we need it, we have the complete gateway with us, which is this gateway. This is me going there and me coming back. And to generate an efficient way to it can only be done through data structure and algorithm. So the best process over there is if I could actually skip one thing, so I'm actually creating things. It could give a strain in my hand, but it's taking me from one step, right? So this can be one of the this can be an algorithm which is using too much of space, but the time frequency too much of space, but the time complexity is being decreased. So right here when I'm going over there, I'm taking one step out of it. It's basically giving me much it increases the time for it, but it saves me from one step, right? So it's actually saving me from one step. Okay. For example, if we want to
I guess this was the video for it. So because it was it was so the audio is not very clear. Yeah, I tried to do the audio, and I really wanted to explain this part where I am on the swing, because this is a very important part if you can see. So if you can just follow my cursor, if you see this thing, complete thing can be taken as a full stack application. Okay, just imagine this is a complete full stack application. Okay, if you're just following, just say yes if you're able to follow. So I generally have some people in the class who always say yes or respond to. So Raj, Omkar, Pranav, and EDM Tech, let's have you as our yes ambassador. So whenever, if you understand something or if you have something I have made clear to you, you can say yes. Okay. So this complete thing, this is a full stack application. Okay. And as I have named it, that this is a API gateway. Okay. And this everything is manipulated data. For example, if I have to fetch something, if I have to fetch a request, if I have to do something, for example, I'm fetching something, I will go from one step to the other step to the third step to the fourth step. So this entry, this complete entry should need to fetch something from over here. Okay, but I need to follow this, right? I need to follow this so I don't fall off, right? We all have done monkey bars, right? We have done monkey bars, right? Yes, gang can always answer. Yes, we have done monkey bars, man. So it was one of my favorite things. I used to only do it till 2, and I was like, okay, mere se nahi ho raha hai. So yeah, it was a very funny thing for me. But it's you have it's I love it. I kind of love it. So these monkey bars, they give you the impression of where data is being transferred from and how data is being transferred from. As I've said, that it's not conventional for, I have gone through many resources for data structure and algorithm, and audio is not clear. Okay, is it now? Is it better? Is it better in any way now, guys? Okay. So, coming back to it. So, as you can see, what I'm doing over here is I'm just going down to the slope, right? I am just following every monkey bar over here. So, this is actually what is happening. It's audible and clear. Thank you so much. So, yeah. So, this is basically what is happening over here is I have to do a step-by-step function to it. I have to do step-by-step operations to it. So I can go from here and I can fetch the data from here. This is how API works. This is how basically our API works. So this thing to work, we have to do it with a very efficient way, right? Because for example, if I'm making a payment through PhonePe, or for example, if I'm making a payment through Paytm, right? So if I need to scan it, it goes to the server. So these are all API calls. So they just can't take forever, right? If, for example, if it takes half an hour to do a Paytm payment, it'll take forever, right? You'll be like, okay, yeah, I'm not doing the Paytm payment, I'm going to use cash. So why Paytm is preferred so much? Because it's very fast, and because the API call is very fast. And why is that happening? Why is that happening in the first place? It's because of how they have used different algorithms and how they have used data structure in the operation, so it's so fast. So you have to understand the concept. You have to get the essence of data science for it. How many of you have done data science earlier? If you can tell me, like you have done data science, you already know how data structures, I'm sorry, and you know algorithms and you've been practicing them. So if you can tell in the chat that you have been already doing it, so it'll give me a more mature, I'll shift in a speed, in a good speed. So I told you that how data is working over here, how I'm going from over here to there, right? And this is the last thing I really want you to explain. So this is a seesaw, right? We have all seen a seesaw. Yes, gang, you've seen a seesaw. You have done a seesaw. Yeah, you have been doing. Okay. So yeah. So what is a seesaw? Seesaw is basically, it balances the weight here and there, right? So now the best part about this is part about the Seesaw is this complete thing. This Seesaw is the best example for time and space complexity. Not an issue if you're not learned it, because I think I am taking it from seriously very scratch. Like we started from bricks, right? So it's basically time and space complexity. So take this as time and take this as space. I'm gonna discuss time and space complexity. Don't be like, oh, he has not discussed time and space complexity and he's telling us I will discuss. Chill. So, but I'm telling you something very prior to it. So, whenever someone says that, okay, time and space complexity is gonna play a role, just imagine a seesaw happening with the algorithm. Okay, so your algorithm has to balance this seesaw to be in a very good play and to be used everywhere. So, it's all about the balance what we have to create with data structures also and with algorithms also. So, time complexity analysis is one thing which is very much required. You should know about it. I'm going to tell you more, but I think I have told you from the bare blocks, right? Because in the first section of the video, when you saw that I told you about different things, right? These are these concrete bricks which are stacked behind me. And yeah, I should remove my ugly self. Yeah. Okay. So very less of my ugly self in this frame. Yeah, so in this, what is happening over here? You can see there are concrete blocks. They are stacked somewhere, right? It could have been stacked in a very vertical manner. It could have you can't see you can't see me. Okay, I don't know what no stands for, Abhishek. So then we have it is stacked in a horizontal manner. So it's the way it has been stacked, right? So it could have been stacked in many possible ways. But why it has been stacked in such a way? Because we had to save space. We had to save time to the moment we have to take these concrete bricks and use these in actual buildings, right? So it's going to save time. For example, if I do horizontal all the way, it's not going to save me so time, because I have to go there, I have to pick that brick and then use that particular brick, right? Okay, it's fine, it's fine. I guess I'm starting from very bare bones, and if you don't understand a thing, you can always reach out to me anywhere. You can always reach out to me Discord channel. You can always you can reach out to me. Okay, so this is where I can show you people have started. Now, over here you can see I just kept a block of brick and I was like, okay, what is this block of brick? Uh, okay, that is fine. That is really fine if you haven't done too much of data structure and algo. So I have kept this block of brick, if you can see. And I told that this brick is acting as a front end, right? So what is this brick? This brick is also a manipulated data. So we get the data from the backend and we manipulate it to become in I guess in this frame. Okay. So in this frame, I told that this is the backend for it and this is supporting the front end for it. So this manipulation of data, if you can see, there is a manipulation of data to support this data, to support this front end. We have stacked the data in the way it could have been supported. So this is a very physical thing. You must be wondering, Array, why he has done so much with the physical thing? Where is the terminal? So just don't worry about it. We are going to have the terminal in some time, because the moment you start to get the essence of what we are learning and how we are learning it, it's gonna be very great when you learn it. So this is the front end, and this front end is supported by this through data manipulation. Okay. Now, the moment I go back to this full stack application, if you can see, so I'm a man of examples. I can't do anything without an example. So when you see this full stack application, you see there are different operations and relationship happening with the data. So this is all connected through this yellow bar, right? This is all connected through this yellow bar. And this yellow bar is basically you can jump from one to other to the next segment of data, right? You can just getting from one relationship. So the relationship between these is this yellow bar. So if I give you very bare bones example of what is data structure and how data structure works. So this is basically data structure, nothing else, nothing else. And if I give you what software engineering is, so how many of you are aspiring to become a software engineer or are a software engineer? If I can know in the chats, that would be great. Are you aspiring to become a software engineer? Are you preparing for it? Because see, the moment you do it, yeah, the moment you do it, you understand the complete essence of what is engineering. So you have to understand what engineering is before jumping to the terminal, before jumping to anything. I believe you should understand what is happening, right? So when oh, nice. So when we are actually preparing for these, so my complete session is gonna be for how to prepare for placements and what are the things which are required for placements. So the basic concept is what knowledge do you require for it? Okay, so you would be wondering why this guy is not telling us data structure. So I'm actually telling you how to prepare for it and what process we are going to follow in this complete thing. Okay, so this is our knowledge base, and this is what we are going to follow. Okay, so for foundation, what do you require? So you started doing data structure and algorithm, you came to the class, but the problem is when you go back to your own terminal, what would you require? So I say there should be a foundation language. Okay, okay. And that foundation language could be anything. It could be C++, it could be Python, it could be Java, it could be anything, because it's the way we are conversing with ourselves, right? So these, I'll just recalibrate this pen. This is very bad writing. So this foundation, how we are going to take the foundation of this particular thing, it's only because you need to know one language, and you can just start today itself. It's not a problem, and you'll just get to know the language. You can start with C++, you can start with Java, you can start with Python, anything you're comfortable with. So you should be comfortable with. I am not a C++ or a Java person. I'm a Python person. But I have few friends and I have a few people who are going to help me to give you the context in C++ and Java as well. Then comes the play for data structure, right? So data structure, what do you require? So the what is data structure, right? Data structure is basically this are the tools required in problem solving. Okay, so what you're going to do over here is solve problems. What a SD does is solve problems. That's it. So this is your set where you are a problem solver. Okay, so this is where your play comes in, where you will solve the problems and you'll be like, okay, I'm going to solve problems for it. So let's focus to the core of problem solving. Okay, and what do you need to understand in data structure? I'm going to practice more on my writing on this, right? So see, first we need to have a problem solving skill. Okay, we need to focus upon our problem solving. It can be anything. If you have given JE, you remember in maths what we used to do? We used to take around 100 problems of the same thing, and we used to do it again and again and again until we are very okay. So there were two kind of people. There were smart people and there were dumb people. So dumb people like me, we used to do too many examples of the same thing. So we always understood that thing and we were kind of habitual to it. So I used to do that. and then there were smart people who used to see a problem and they actually solved it. So, but we have to see a problem and actually solve it and get habitual with the problems before. So the algorithms we are going to tell, the problem statement we are going to do in future, they are going to be very similar, and they are going to follow a path, the path which is required for placements. Then after problem solving, we have math plus complexity. Okay, so if you're not great at math, not a very big issue, because it's something which you can generally be good at in some time. It's not something, and believe me, if you have prepared for engineering, I guess there are CSE students, and if you have prepared for engineering exam and if you have passed class 12, I think you have done almost 80% part of it. So I guess you would be good with that. And so we data structure is something which can go on and on. It's something which will go on for years. So for this session, we are going to keep it limited. We are going to keep it limited to only placements. Very bad. I don't know why my input is so bad with this. So we are going to keep it very limited with this. And moving on to the next part. Okay. So I told you what is data structure. I guess you understood what is data structure. So this is very introductory class, because there are many people who have not understood what is data structure and why do we really need data structure. Okay. So when we move on to the interior part of data structure, so how data structure is happening and why it's taking place. So there is a formation to it. Okay. So if you are very noob and you don't know before this what data structure was, I feel you must be confident after looking at this, after my video and everything, that you know what is data structure. Coding is basically manipulation of data, right? And manipulation of data, it can be manipulation. I feel like a doctor. Yeah, of data. So the manipulation of data, it can be distributed into three parts. Okay, structuring of data, how you structure the data. Okay, फिर organizing the data, and the last thing is managing data. Okay, so this is basically what coding is. So manipulation of data can be distributed into structuring of data, organizing of data, and managing of data. Okay, so how many of you use email out there? Do you guys use an email? You can say yes, yes, I use Gmail. Yes, I use. How many of you use an email? If you can tell. This is cool pen. How many of you use an email? If you can just tell me in the chat. Yes, you use an email, right? So what does email does? What is why do we use an email? And so it's a very basic thing for a communication, right? But you really don't know that email is the best example. It's the best example of us organizing a data, structuring a data, and manipulating a data. So unknowingly, you have been doing data structures all your life, right? So you have this very huge data with you, and you have been using it to receive mails, and you have been using to send out mails. For example, the moment you have been receiving a mail, right? So how a mail is tagged? Have you seen the way a mail is tagged? It's like this. It's like this. It's like this. It's like this. A large set of emails into it's from X Y Z, Y Z X. We all are in YouTube, so obviously brownie points to you. So this is how you have organized the complete data in a vertical format, right? So this vertical format, and we have organized this data in this vertical format. And the moment this vertical format, okay, yeah, I got a hang of it. So this vertical format is how the data has been stacked and we have kept. Now in this, you have different folders for it, right? You can have spam. I'll tell that later. You can have spam. You can have important mail, right? What you have done over here is you have created different folders and different sections for it. So you have a large data. You have organized that data into different folders, and some people like me who are very particular with their mails. They have also filtered their data. They have filtered their emails as well. So over here, what you have done is that you have an email with you. You have this vertical stack of the email, and then you have given different examples. You have given different folders to that particular mail. So what you have done, you have a structured data, right? This is a structured data. You have organized it, right? And the moment you send out a mail, you have manipulated that data. So this email system is basically what? Is basically a data structure. It's a very good example for a data structure. I guess you understood my point. So the mail we have been using for so many years. Now, did you know that? Amazing. How will this figure go? Oh my. Okay. So yeah. So you see, email was the form of data which we have been doing, and it's a particular way how we have kept the data, how we have organized it. So this was the form of uh, data structures. So now I'll go with the bookish language that what people have told. Okay, so what Wikipedia has told about data structure, it's the collection of data values where you can have different relationships and operations over the data. It's the collection of data values where you can have different relationships and different operations over the data. Now I will do something which I think you would be very familiar with, and that is, I guess, this is something which rings a bell, right? Which rings a bell. You have seen this form, right? Been so many years, and I guess you would be familiar. If you are a computer science student, you would be knowing this. You would be knowing this, that this is a very familiar form, and why not? So this is a very familiar form, and you see over here, what is this? This is a data value. This is basically a data value. And what is this? This is a relationship. Okay, this is a relationship. And over here, for example, 2. Okay, if I want to replace 2 with 4, okay, and I want to do that, I want to replace this particular thing. So what is happening over here is the operation for it. Okay, so I guess I'll shift to the full screen video because मेरे को देख के क्या करोगे है ना? So I'll just shift to the complete video, and I'll explain it better to you. So if you lose out my audio or something, you can just tell me that. And because this is something which is very important, you need to understand, right? So you understood what this is. Now let me tell you something which I would be more familiar with if you have been knowing it. And please don't be scared that what are these, what is happening, I don't know. See, it's my job to tell you that what is this and what is happening. Okay, so this over here is your data value. Does it look similar to anything? Do you think this looks similar to something? Ah, nice. Nice, buddy. So this is a tree, and this tree and this over here is the relationship. Uh, this guy has two relationships. So yeah, this is the relationship this data value has with this. So this thing is a relationship. And if I really want to do an operation, and if I really want to remove this guy, okay, you're having two relationships, we need to remove them. We need someone with more audacity. Let's have 101 over here. So this is a operation. Okay, so we have this data value, we have this operation, and this is the relation. So this is a tree. So see, there are, so the things you need to focus upon is data values. You need to focus upon this operation, and you need to focus upon this relation. Okay. So these are the things you really need to focus upon rather than anything. And there are many ways that you can stack a data. And in future, you would be learning that there are many ways that you can stack a data, and you can know, okay, a data has been stacked like this way. And but the thing which would not change would be data values. Relationships never change. They're always there in your life with everyone, with people. And then the operation, for example, if I remove it with e, so these things are always going to happen. Okay, so what is consistent with everything are these things. Okay, so you need to focus upon these three things: data, relationship, and operation. Okay, and after that, when you just very good when you just get great at it, all you need come to know that there are things which are just changing, and these things are going to be the same over the time. Understood? I guess if you have understood till this point, just tell me. Very short break. Matlab if you want to have something, if you want to drink water or something. So have you understood till here? Have you understood what I've told? Yes or no? If there is something you have missed, I have started from. Okay, great. Now we come to the play. You remember the seesaw? You remember the seesaw? What I showed you guys, right? You remember this, right? You remember this complete thing. Uh, this and this. This was the complexity. Okay, so if what I was explaining you with was this complexity. So now what I'm going to explain you is complexity analysis. Okay, we are going to have a complexity analysis over the thing. So these are the very basic things you need to know before jumping into any algorithm or any concept, because this is something which is very much required knowledge. Just say, for example, when we enter the plane, right? They tell us कि दरवाजे इस तरफ हैं. Okay, uh, my video is not on. Yeah. So they tell us, right? दरवाजे इस तरफ हैं. There are doors here and there. You can just follow this script. So this is what I'm doing right now. I'm telling you, okay, we are going to take off like this, and I'm telling you a bit deep as well. Okay, the pilot is going to start the engine and how the engine is going to work. So I'm giving you a very high level eye view of it. I'm not going into, so if you have a CS background, you know these things can be done very deeply, and I can explain you very deeply. But I am explaining I'm giving you a high level view of this. That okay, this is going to happen, this is going to happen, this is going to happen. So you are familiar with it. Okay. So now coming to complexity analysis. Okay. See see how my writing went very great. Okay. Complexity analysis is something which is required to understand data structures. Why data structure is happening, why this program is running, why I have taken a variable and it's working. So these things, these complete things, why complexity analysis is the whole and sole reason why it happens. So complexity analysis is something which is a foundation for computation. So this is a foundation for computation. Now, if I need to really explain it to you, so this is a very great author has told that complexity analysis is the bedrock. वो seabed rock होता है ना? If you have seen very deep sea, or if you have seen movies like this, so there is a seabed. So if you have a sea, if you have a ocean, उसके ऊपर ऐसे एकदम मस्त 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 ओशन है. ओशन के नीचे 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 जाओगे तो you'll see there is a bedrock, and you'll be like, okay, nice man, there is also land beneath it. So this is called a bedrock, and this bedrock is complexity analysis. And this blue pani is your data structure, and this let me remove this. And this thing, this complete thing over here is a I have a small boat, and this small boat is your problem. Is basically your problem. Okay, so your problem is floating on the border of data structure, and complexity analysis is the bedrock for it. So this has been so if you go through books, I'll just suggest few good books if you can go with data structure and algorithm. And if you are very clear with these concepts in life, of data structure and algorithm, you will never face a problem in doing any problems ever. Seriously. And I really mean this, that if you're very clear with this problem and you know what you have been doing, so you'll not face a problem in your life. It's that easy. So, as explaining it to you, so in data structure and algorithm, why we need complexity? As because if I have a question with me, if I have a question with me, okay, this is a question, and for that question I can have multiple solutions, S1, S2, S3. So there are, for example, for a problem statement I can have multiple questions. For example, what example I could give for one thing, and L'Oreal bhai, one hair, one shampoo, five solutions. L'Oreal is the best example for it. So this is also like L'Oreal, man. So, but you see, every solution is not equivalent. So L'Oreal ka thoda, this is vice versa of L'Oreal, because that is five problems, one solution. This is very much ulta to it. One problem, many solutions to it. There can be three, four, five, many solutions to the same kind of problem. Okay, and how it can be same? See, the only thing which can change is obviously the syntax, and sometimes the time and space complexity. Here comes the play of time and space complexity. Now you must be wondering, ki, yaar, Prakash, you just said ki we had to balance, right? So whenever you're giving an interview, the interviewer will ask, your answer is right. He'll or she will say, your answer is right. But can you make it efficient? Can you even do that? You must be wondering, yeah, I can make it efficient. I can do that. I can do this or that. So you'll think. And here is the play why It's required. Here is the play. It's required to know time and space complexity. So now you must be wondering, can the solution be better? Is it possible? Can I make the solution better? Like you think, can the solution be made better, or should I do redo the complete solution for a question? Think, just give it a thought. And what makes, and if you're going through complexity, okay, complexity is not something which you think is the complexity of the answer or complexity of something. It's it's very different from it, what you are thinking. If you're going through the difficulty of this thing, it's not that. It's basically not that. Complexity is divided into time and space. Okay, so let me explain you the time position over here. Here, the only thing I'm scared of my writing on this. I'm gonna improve. I'm gonna go very. I'm gonna improve my writing. I never thought I would be writing on this ever, but okay, it is what it is. And so the time and space complexity. So over here, when I go with time, right? So you can understand what is a time complexity. Something to computate, it's taking too much time, right? It's taking too much time to computate that. So that is a time complexity. Simple as that. For example, if you're running, for example, if I'm running this program and it's taking too damn long, so why would I go with this, right? I gave you an example of Paytm, right? I gave you an example how Paytm used to work, and I gave you an example of. So let me draw one more thing. So for example, you are at a shop, okay? You are at a shop and you need to make a payment, and so imagine you are at a store. Okay, इसके लिए I require the video. So you are at a store. So every mummy in store is like, you are in a very mega store. You have trolley in your hands and you are just going to get the payment done. Okay, and your mummy is gonna be like, okay, I'm gonna just be there in few minutes. You just stand here with the trolley in the line. Okay, just do that. Please, if you could do that with me. You're standing there. You have to pay in some time. Okay, over here, what is the most required thing you need to have? Money, right? You need to have money to pay the cashier. And over the money, you need to have this time complexity with your card or with your payment gateway. You need to have that, right? Because if the time complexity is too much, but the space complexity is too low, it's not very useful at all. Because if it's taking half an hour to do a payment, the system's gonna fail because it's not gonna work. So this is what is time complexity and how we work, how we are working to reduce this, and how we are working to make things efficient from this. Okay, understood till here? This is a very light session. This is a very light session. If people came high hopes with Astrolinkless Toga, not right now. We'll do step. So I believe in baby steps. You need to have good fundamentals, then only you can understand bigger things. So I guess you understood what time complexity is. Now let's go upon space complexity. So you must be wondering, what is space complexity, right? Space complexity is something. Okay. Space. Woo. So space complexity. What do you think is space complexity? Okay. So I'll tell. Space is basically how much memory you use. Okay. The used memory. And I can give you a very great example. Just open my task manager. See, over here, if you can just see how much memory it's being used, right? What is right now happening? If you can see, you can just open your task manager and know it. So there are different processes running in the background, right? And the memory it's consuming. And my God, Chrome is Chrome is a very B. So Chrome is, see, if you can see the memory it's been using, right? and the memory it's been taking to run the process to be very much implemented upon it. So this is what is space complexity. So I guess you understood what is time and space complexity. I just gave you an overview. I didn't went through, but now my job is to tell you that how you can create things which are a better solution. Okay, so we need to reach better solution. More than anything, we need to have a better solution. Okay, and how to have a better solution. Okay, so better solution can be better time complexity, right? Better time complexity and better space complexity, right? You understood my point. So this is how you balance between things and you create a solution which is better solution, right? So you need to find this better solution in your 1 to 2 hour or 3 hour of the complete process which is going to take place. Okay, so I guess you have understood till here. Very elementary things I'm telling you right now. Very elementary things. It's not something, because अगर तुम्हें किसी भी टाइम पे लगता है ना कि यार this is very heavy for me, Prakash, I'm not going to able to do this, you can ask in the Discord channel or you can ask in the chat as well. Okay, so now let me explain a very important thing to you. Okay, so this, if you remember, okay, these were data values, right? This was relationship. This you really need to understand. Okay, we are at full, right? And this is relationship. Okay, we have just did this few moments before. Now, for me to balance time and space complexity, I have to balance time and space complexity. And how this is going to happen with every operation and function. So this is an operation and function. Okay, so for every operation and function, what you need to have is you need to balance the time complexity between a you need to balance time and space complexity between a relationship and then between operation and function. Okay, so this time and space, this is called time and space ramification. Time and space ramification, RAMIFI, ramification. So why this ramification is taking place? So we have to balance thing out. So we have to balance the complete thing. Okay, so these were data values. Okay, there is an operation and function happening over here. Okay, where the moment we have been done with this time and space, what we are balancing out the time and space between the relationship and the operation and function. Okay, so you need to imagine ki bhai, now you have to imagine that thing ki we have relationship. Now imagine that seesaw. Okay, now imagine that seesaw. Over that seesaw you had time and space, so you are balancing out time. I'm going to save you some time and I'm going to write time and space. Okay, and this is operation and this is operation and function. Okay, and this is relationship, and you are balancing that out with time and space. Understood my point? So you are balancing time and space with operation and function with the relation. Understood till here? समझ आया नहीं आया? Have you guys understood anything? कुछ हाँ ना yes no ha ha he he रिंकिया के पापा मतलब anything guys. If you have understood, just say okay, and if you haven't, you can say that as well. Okay, and I'll come back to it. Okay, cool, 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 cool. So this was a part I really needed you guys to understand. Okay, so the next part. Okay, so the next part is very. It's something which is I'm gonna cover it in the next class as well, and we are going to jump to it in some time. And the next part is, so you have to think of few questions. Okay, whenever you are solving a question, okay, always remember this: which is the best data structure? Okay, and which one is the, so this is a plus sign. Okay, so how relationship help in balancing time and space complexity? So see, relationship is not helping it to do it. Time, it's the job of the time and space complexity to be handled by you. You have to find that point, right? You have to find that point that you are going to balance time and space complexity with the operation and function and the relation. There are times, right, when you used to do a seesaw, you used to balance the other person and the other person used to balance themselves, right? So that complete movement, what you really need to think about is that at one side there is operation and function. There are things happening on your linked list, there are things happening on your tree, there are things happening on your heap, whatever it is. Okay, and now you have this relationship. This is how these things have formed. For example, if it's a linked list, for example, if it's a tree, there is a relation between them. That is the relation between them. ट्री एक रिलेशन है, लिंक लिस्ट एक रिलेशन है, तो तुम्हें उस रिलेशन को और उस ऑपरेशन एंड फंक्शन को बैलेंस आउट करना है. और टाइम और स्पेस कॉम्प्लेक्सिटी क्या है? टाइम और स्पेस कॉम्प्लेक्सिटी, फॉर एग्जांपल इफ यू डिफाइन अ वेरिएबल, तो क्या होता है जब तुम वेरिएबल डिफाइन करते हो? व्हाट हैपेंस व्हेन यू आर डिफाइनिंग अ वेरिएबल, राइट? हाउ डज दैट वेरिएबल इज कंप्यूटेड? So that is where time and space complexity comes into play. Understood? If you haven't, let's get in a chat in after some time when I'll complete the class, and I can surely help you with your doubts. Okay? And so this is the complete thing. So whenever you're doing a question, you need to think what is the best data structure for it, and what is the best data structure, and how I can balance out the time and space complexity with my solution. Okay, so you need to find a better solution. More than a solution, your job is to find a better solution. That is what a software developer is. Oh, let me grab some water once. Okay, I hope you guys have understood till here, because I have been very slow. I have been explaining you one terms over here, but the moment you think, okay, I'm not able to understand it, you can always ping me in. Now, the next part. So this is going to be the final part of the class today. Okay, and this final part is, so this final part is Maroon 5 memories. No, just the memory. Okay, what is a memory? So there is one more layer to this complexity analysis, and we can talk about hours and hours on memory. Okay, so but as I have to keep it very constricted to things, so this one layer, I am keeping it for this one layer is memory. And you would be thinking, Prakash, I think time and space complexity meant the same. Why you are telling us about the memory right now? So you need to understand. You need to understand what is the concept of memory behind it, and why There are things stored. So whenever someone says mentions you memory, and these are asked in interviews as well. So I was going through past year questions of different companies and this year's questions of different companies. Memories question are everywhere. Maybe it cache or maybe it anything. And see, I'm not gonna go very deep in it, but I'm gonna tell you how memory can be used and how they are used. Okay. So whenever someone says, okay, we are going to speak about the memory, what is the first thing that comes? So yeah, that this is the problem with this YouTube thing is that there is no interaction from the next end. I really don't know what you have understood and what you haven't. The start function is, but you know, right? That connection, well, that is not right there, right? So let me draw this complete thing. So whenever someone mentions memory to you, you should be thinking, okay. So for example, if I'm declaring a variable, okay. So, for example, if I am having a variable, okay, variable one, and variable one is going to be 10. Okay, so this declared variable, where has it gone? Where Google Meet? बहुत शोर होता है Google Meet पर. People are like, can you please mute? Can you please mute? I really just don't want to do that. So yeah, variable 1 is equals to 10. Okay, I have given this variable. So this variable, where it has been stored. So you would be thinking, right, here it has to be gone somewhere, right? You have just given it to the ID, okay. Take variable as 10, okay. So ID is like, okay, I'm gonna save it. And that okay thingy, where is that okay thing is going? Where is that ID storing that? That is memory. So whenever memory comes to your mind, oh, I guess, okay, 1 hour is done. Okay. So whenever memory comes into your mind, always remember when it comes to my mind, what I do is basically make this kind of structure. Okay. So whenever it comes to my mind, I make this kind of structure and I know yeah, what this structure consists of. Okay. So how things are going to be saved in this structure. So guys, I guess this would be it. I am going to explain in the next class. So memory was something which I was going to start, which I was going to start in the next class. But we have just come this far. So this is going to happen in the next class, and I'm going to explain you how memory works and everything works. See, my goal is not to go like every other YouTube tutorial. I don't have that goal. My goal is for you people to understand more than anything, more than any. I really don't want a name for myself. I really want you guys to understand, and that is up to you how you really take this. I guess today was a very small pill I gave you, and I hope you have digested it. If not, you can always reach out to me on different channels, different social media, and I would love to answer you. And thank you so much, guys. Thank you so much for having me. And बस यार हो गई क्लास थक गया यार so see you next time and let's go with memory and let's take it into let's go deeper into the thing and we'll enjoy it. Okay, see you guys. Please, and one more thing, please do give me a review. So you can always tag me on @Prakarsh Patak 0 on Twitter, and you can give me your review. How was the class, and how I can do it better? How was it was? Did I didn't tell many technicalities were not there. How? So you can just give a feedback. It's very most important thing for me, a feedback. Bye guys. See you.